Okay, so we're going to get into log rules. I'm sorry, derivative rules for exponentials. And we sort of done this already. And I promised you a video on the definition of E. And what is E? Well, we know E is 2.718281828, etc., etc. But I want to know how do we get that number? Where do we find that number? It's, pi is the ratio of the circumference of a circle to the diameter of a circle. Where did E come from? Okay, so there's a lot of good videos out on the internet about that, but I'm going to just sort of add to that. Okay, so you got this function, 1 plus 1 over a raised to the a power. And I'm not even going to I'll sort of get into that. I'm not going to get into it. Just look at this 1 plus 1 over a to the a. Okay, so imagine that somebody's going to lend you money at 100% interest, and they're going to compound it every year. So at the end of the year, you owe the dollar that they lent you plus another dollar at 100% interest. Now suppose that they're going to compound it every 6 months. So every 6 months, at the end of 6 months, you owe them $1.5, and then they compound that again. I don't really want to get into compound interest right now. But compound interest, instead of owing $2, you owe $2.25. Well, let's go bigger. Let's make this number bigger. And now it's more, 2.704. Okay, well, let's make it bigger still. 2.718. Well, it's getting bigger, right? Let's make it bigger still. 2.71828. Well, let's make it bigger still. It's still 2.71828. So basically, E is the number that you get when you do 1 plus 1 over infinity raised to the infinite power. So that's one definition of E. E is the number you get when you get 1 plus 1 over infinity, all of that raised to the infinity. Okay, another way of thinking about E. Let's look at y equals 2 to the x. I'm going to graph y equals 2 to the x, and I'm going to do our slope thing. So what I'm going to do is I'm just going to click on a point. And so I got the point 1, 2. And I'm going to zoom in on that. Boom, 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 boom. And I'm going to displace by just a little bit. And, well, I'm going to actually sort of back it up a little bit. I'm going to move over just a little bit. And I'm going to get, basically, my change in my y is 434. My change in my x is 313. So the approximate slope of that line is going to be 434 divided by 313, which is 1.38 or 1.39. So what I'm saying let's zoom in just a little bit. Okay. the slope of this line at the point 1, 2 is approximately 1.38. Okay? So now let's do another function. Y equals 3 to the x. And let's find out what the slope of that line is at x equals 1. Okay, so I'm at the point 1, 3. And then I'm going to choose another point just a little bit next to that. And I get, basically, I'm looking at 515 divided by 156. So the slope of that line is 515 divided by 156. And that's 3.3. Okay, now what I don't really have time for, well, actually I do have time because we'll just take the time. Let's do another one on the red. So we're at the point 2, 4. And then we go just move it a hair, and we get 1737 divided by 625. And we get 2.7792. And one more just to humor me. Go in here, and we're at the point 29, and we go just a little bit, and we get 6201 divided by 625. 6201 divided by 625. And I get 9.9. Okay, so what I want to show you here, which is a little bit hard to see, is that the slope for this function y equals 2 to the x, when the y value is 2, the slope is 1.38. And when the y value is 4, the slope is 2.77 or 2.78. For this function, where y equals 3, the slope is 3.3. And for this function, and when the y value is 9, the slope is 9.9. Okay, so I want to write this out in text. Okay, for the function y equals 2 to the x, the slope is always a little bit less than the y value. And for y equals 3 to the x, the slope is always a little bit greater than the y value. So There should be some number between 2 and 3 where the slope is equal to the y value. And if you look at these numbers, you're going to see that 1.38 is a lot farther away from 2 than 3.3 is away from 3. So I'm going to say that the number is going to be closer to 3. And it is. So if I do, let's take all this away. 0.718. Let me just make sure I got it. Seven one eight 2818 28. Let's do that. Okay. So here I'm at 2. Let's zoom there. Okay. So I gotta write these down. So I'm at 2, 7.38906, and then I'm gonna move it a little bit, and I'm at 2.00625, 7.43538. And so then, if I do 7.43538 minus 7.38906, then I divide that by 2.00625 minus 2, I get 7.4112, which actually, if you think about it, I wanted to find the slope at sort of this point, but if you think about it, this is going to be sort of the average slope between this point and this point. And so what's the average? Let me just do that real quick. Equals, let's just do this. Copy, paste. Sorry. Look at that. So there's my average. So the average y value between y1, so there's my y2, there's my y1. The average between those is 7.412. And my slope, my average slope of that line at that in that area is 7.4122. So E 2.71828 ... is the number whose derivative so E is that number where if I graph y equals e to the x, the slope of that line is e to the x. Okay, that's that video.